One of the commonly used equation in approaching quadratic equation is the quadratic formula, which is x b negative b plus or negative the root of b squared 4ac now over 2a. As we know, the nature of a quadratic equation is the form of x squared plus bx plus c. Now, we want to make it a perfect square by trying to we try to complete the square. The complete the square method by doing what we do on the right, we also do it on the left. This we try to make sure that this side this stay to 0. So our equation we are trying to make it actually a perfect square, and then to make it suitable, we have to remove these coefficients of x such that it stay to be not actually greater than 1, because we don't know actually what is it, and this means that our equation remains like this. In this case, we can now introduce c, because we want to make actually this a perfect square. C is actually always like that, and in our case we can see that our c here is actually b over a, the coefficients of x here, and we have to square. Actually, when you do this will actually be, because you can first, it's actually b over 2. Actually, this is over 2. By opening it should give actually b squared over 4 a squared, b squared over 4 a squared. We add on both sides so that we have x squared plus bx. We actually work on both sides on the same. We add the same, and by this, in this case, when you try to factorize this side, we're actually going to remain with x plus b actually over 4a, but this have to be square. Actually, it's not for 2 because we are factorizing, not it's actually 2. And in this case, in this the other side, we can actually find the LCM, which is actually 4a squared. In the first case, we are going to have negative 4 AC, because one of a says 2. In the other case, we are actually going to have b squared. Let's put this such as it's equidistant by alternating, but we are not changing anything. We have just tried to make it look actually more perfect. Now our main equation, on the other side we had this, which of already square. On other side we're going to have this, at this step we can just find the roots of both sides, so this and this, and we all what we know what will happen to that side. Actually, we are going to remain with this, and sorry for that. Actually, I was doing this outside a house. That's the reason why. Okay, then we, on the other side, we have the roots. Actually, because of introducing the roots here, we must also indicate that it's either negative or positive. With this case, now we can bring this to the other side such that we remain with this, the roots and this will be negative, of course. What I want to do, because of this, we already know we can actually simplify this, because this we can find the root of this. So let us simplify by just indicating that. Let me just, we are here, let me put it on this side because of the space. We have said we can just simplify this side such that